Assalamu alaikum, students. Today I came with another video, and that video is on circles. And these circles are basically related to the IGCSE 0580 course. And I'm preparing this video with the purpose of preparing my students for end of term 3 final exams. So you can see I'm going to start from question number 55, and all the questions related to circles I will explain in this video. Guys, it's very clear in this question number 55, we have a semicircle. So if it is a semicircle, try to see where is the diameter. So I'm just highlighting the diameter. So AB is my diameter. The property which we have studied in the circles, that if the endpoints, yani A and B endpoints of the diameters are joined anywhere on the circumference, at that point, yani at point Q, we must get a right angle triangle, any right angle. Okay, so this is 90 degree. Now, if this is 90, by using another property of triangle, which says that if the two sum of the two angles, or the sum of the three angles in a triangle is equal to 180, if the sum of the two angles is subtracted from 180, you can find the third angle. So this third angle will be what? It is 180 degrees minus 29 plus 90 degrees. It will give you 61 degrees. So it's a pretty simple question. Which properties I used? I use right angle in a semicircle. And second property I use it angle sum of a triangle, which is equals to 180. If you know the two angles out of the three angles, you can easily find the third angle. So let's go to the question number 56. In question number 56, the things which you need to see, number one, the diameter, guys. What I said in my last question, if the endpoints of the diameters are joined anywhere on the circumference, you always get a 90 degrees. So this is 90. Now, as you know, the two angles in this triangles are given. I can find the third. Yani what will be my x? My x will be 180 minus the sum of the two other angles, 90 plus 55. It will give you 35. It will give you 35. So I'm going to label it 35. Another property which is telling you a radius or a diameter is always perpendicular to which line? This line, which is serving here as a tangent line. So this is your tangent line because it is touching the circle at only one point. I cannot say AC is a tangent line. It's not a tangent because it is cutting the circle at 2 points. Okay. So what is the property the tangent and the radius have for the circle? They are always intersecting at 90 degrees, right? So this is 90 degrees. So I can easily find the y, so which is 90 degrees minus 35, and that gives me 55. Clear, boys? Next question is, if you see, so what are the properties I used it here? So number one property was right angle in a semicircle. And second property is radius is perpendicular to the tangent. And the third property is angle sum of a triangle. equals to 180. We use these properties and found the angles which are required. Question number 57. You can easily see here there is a tangent, sorry, there is a diameter, and if there is a diameter, then the endpoints of the diameters, if they are joined anywhere on the circumference, we always get a 90-degree here. Secondly, isosceles triangle. And in the triangle ABC is isosceles because AC side is equal to BC side because of this. So which special property of isosceles triangle we are going to use now? Isosceles triangle, their opposite angles are always equal. So since BC is equal to AC, so the opposite to BC is angle A, that is X, and opposite to AC, that should be also X. And I want to find X. To find X, what we need to do, we write X is equals to 180 minus 90 divided by 2. Why divided by 2? Because the two angles are same. I can also find it like this: X plus 90 is equal to 180, and then send the 90 to the other side, and X plus X is what? 2X. 180 minus 90, and 2X is equals to 90, and then divided by 2. Okay, it's pretty simple. I'm erasing it. It's not required. It is well understood. The student knows the concept of applying this rule. So the answer comes to me 45 degrees. So if it is 45, okay, now I will use the property again. Which property? Uh, that diameter and tangent. This TU is a tangent line, and the relationship with the diameter or the radius makes with the tangent, they are always perpendicular. So one of the angle is given, so I want to find this angle, and this angle should be 90 minus 45, which will give me 45. So this is 45, this is 45, and that is 90 degrees. So what are the properties I used? I used right angle in a semicircle. Second property is opposite angles in an isosceles triangle. They are also same because their opposite sides are same. Third property, it is the diameter is perpendicular to the tangent. Um, I can also use the fourth property, although it's not needed. This blue angle is same as with this angle. This is called alternate segment theorem. Maybe in upcoming questions, I will explain you. If you see, guys, in the next question, we have here again a diameter, and we have here a tangent. What is the relationship they have? They always make a 90 degrees. So um, one angle is 42, so the complement of 42 will be 48, right? And as per the rule of of diameters, if we join them anywhere on the circumference, they also make here 90 degrees. Then I can easily find this angle, which is 180 minus 48 plus 90, and that gives me 42. So this is 42. So I found 48 and 42. Next, if you see in this particular case, I want to find y first. Guys, in this particular case, you can see it's an isosceles triangle. Which one I'm talking about? This triangle is an isosceles. What's the reason behind it? The reason is OA and OB, they are the radius. And in a circle, the radius is a fixed thing. It cannot be changed. So they will be same. So OA is equal to OB. So then I can say that OAB is an isosceles triangle. So their opposite angles must be the same. So the opposite to OB is 50. Then opposite to OA must also be 50. Then I can easily find y 180 minus the sum of the two angles 50 plus 50. So it gives you, this answer comes to me 80 degrees. Now, radius and tangent, they are making 90-degree with each other. So if you know one of them, the complement of 50 is 40. How did I get it? 90 minus 50 gives me 40. Now you know the two angles in this triangle. Can I find the third one? I'm talking about OAT triangle. So in OAT triangle, 80 and 90 must be subtracted to get you the T. So T is 180 minus 90 and 80. It gives you T is equal to 10 degrees. So let me copy here the answers: 80 degrees, 40 degrees, and 10 degrees. The next question, number 60. We can see here, diameter first of all, where the diameter is joined. The diameter is joined here. So that has to be 90 degrees. The sum of these two angles will be subtracted from 180. It gives you x66. Now, using the parallel line concept, which is called a z concept. So this angle must be the same as this. This is 24. Now, after finding y and x, now I have to find z. Since examiner says that this AB side is equal to AC, if he was not telling us that they are equal, by definition, the tangents from any point outside the circle, they are also having the same length. So it is well understood for extended students that AC is equal to BC. However, how can I get this angle? And then you can apply it. And then this is an isosceles triangle. The two angles must be the same. You remember that, guys? The tangent, sorry, the radius and the tangent, they are perpendicular. So I'm going to find this angle, and that comes to me 66. Is it 66? Yeah, it is 66 wise. So this should be 66. And then angle sum of a triangle property I used. It gave me 48 degree, because 180 minus 66 plus 66, and that gives you the final answers. So our angles are 66, 24, and 48. Next, we have a next circle question. If you see, guys, he said BD is a diameter. Although he did not mention here the center, but he said clearly that BD is a diameter. If BD is a diameter, guys, did he join the endpoints D and D anywhere on the circumference? Yes, at C. So apply the semicircle property. So this is 90 degrees. With the help of this, you guys can easily find this, which is 56, the angle sum of a triangle. And as he said, this is diameter. Now, I have this one 68, and this one I can easily find with which property? the parallel lines property, the C property. The C property tells you if these two lines are parallel, then angles on the same side are supplementary. So we call them co-interior angles. So this is 180. I'm talking about this and this. 180 minus 68, that gives me 112. So we found this angle. So he was asking you what is the reason why it is 90 degrees. So right angle in a semicircle. In the diagram, we have found these angles 56 and 112. Next question. We can see here the parallel lines. This line and this line, they are parallel. Can I use the Z concept? Let me try to make a Z. Yes. So it means that this angle X should be the same as this angle X. Okay. Now, next property, and this total angle is X. And this is 24. The reason is OAC is an isosceles triangle. OA is equal to OC. Both are radius, equal to the radius of the circle. So this is 24, guys. The next thing which we are going to look at, as everyone knows, this is a radius and this is a tangent. Famous property of radius and tangent, they're always 90 degrees. So can I find this angle X will be equals to what? It is 90 degrees minus 24. That gives me equals to 66. So the total is 66. From here, I can easily find y. 66 minus 24, that gives me 42. Next question. We can see easily here the isosceles triangle is seen. So we want to find what? We want to find ECD angle. ECD. So E, C, and D. Okay. So just I'll take a pause. Okay. So if you can see now, guys, the question which I was trying to solve, he said ECD. Which letter is at the center? C. So ECD angle. So this angle is required. So how to reach this target? Um, at first, I will prefer that students will try to use the property which has not been, used by me in within this discussion. What is that? Look into the circle, and there is a quadrilateral. Look, the B point, the A, the E, and the C. These are the four corners, and they are joined with straight lines. AB, AE, EC, and BC. So this is a cyclic quadrilateral, a quadrilateral whose all four corners موجود on the circumference of the circle. Such type of a quadrilateral is called cyclic quadrilateral. And cyclic quadrilateral has very famous properties. What is that property? The opposite angles. The opposite to 45 is this angle. Can I write this angle? Yes, they are supplementary. So this is 180 minus 45. So that has to be 135. Clear? Now, this angle is 135. Let me erase everything. But you know now, I have used the cyclic quadrilateral property. So ABC CE is a cyclic quadrilateral. I wrote it. And then he said AC and CD are equal. AC, AC and CD are equal. So it means this angle must be the same as this angle by using the property of isosceles triangle. So if you know the two angles, boys, 20 degrees and 35, you can easily find this angle. What is that? 180 minus 135 plus 20, and that gives you 25. And this answer angle is also 25. Now, can I write this angle? You remember that, guys? This is 180 straight angle. So from 130, from 180, I subtract 135, I will get 45. Now I think that it's pretty much easier for us because I have two angles in a triangle, and I can easily find the third one by using the property of angle sum in a triangle. So 180 minus the sum of 45 and 25. It gives me, finally, it gives me 110. Let me write it here, 110. Interesting question. How much marks it has? 3 marks. This question is repeated. I'm not going to solve it. Go to the question number 65, boys. So 65, I have a tangent, and this angle, this is a chord. PT is a chord, and AB is a tangent. Remember the property of alternate segment theorem I told you? If a chord is making an angle with the tangent, that angle will be the same as if you produce the endpoints of the chord on any point on the circumference. So why not I can say that this is also 50 degrees. And the name of this property is alternate segment theorem. So this is 50. As per isosceles triangle property, guys, this has to be 50. And then you can find this angle, 180 minus 50 plus 50, and you will get 80 degrees. I'm gonna go to the next cyclic quadrilateral property, boys. This corner, this corner, this, and this. All the four corners of a quadrilateral موجود on the circumference. If they are موجود on the circumference, it means it is a cyclic quadrilateral. And what is the famous property of cyclic quadrilateral has? Their opposite angles are supplementary. So can I say that 3x and 2x, their sum should be equals to 180? So 5x 180. So I'm going to get x is equal to 36 degrees. So x is found. Second thing is, boys, this is a straight angle, 180. Can I find this one? This one is 180 minus 68. That gives me 112. And then this is opposite. W is opposite to it. So I write 180 minus 112. That is 68. So the exterior angle here is becoming equals to this interior angle, but you must use this property. No need to, um, you know, memorize another property on cyclic quadrilateral. Just this is 68. You found this, and then use the supplementary angle property of cyclic quadrilaterals. You can write it 68. So 68 and 36 are the answers. Next, 66th. Boys, in this question, you will see that I'm going to use the angle in the same segment properties. Yani If I'm going to use this arc, supposedly, this arc, the endpoints of the arc, these are the endpoint, S and R, the endpoints. Let us see where I'm going to join them on the circumference, here and here. So this point. And also, I'm going to join S and R at point Q. Which special property we studied? These two angles must be the same, and this has to be 21. And this property called it angle in the same segment. The property is angle in the same segment. When the same arc is used to produce angle on the circumference, those angles will always be the same. Uh, Now, I want to use angle in the same segment property again. Where? Where? Check it out. This is P and this is S. And we have a PS arc. Did I join P and S at any point on the circumference? You will say, yes, Mr. Romer, you have produced them back at R, and I am also producing them back at point Q. Wow. So this is AT. That has to be AT. Clear. So again, I used the angle in the same segment property. So with the help of angle in the same segment, guys, I have written so many angles. Now, what is the thing which I want first? I want to find PQS. The first question is PQS. Which letter is in the middle? Q. So PQS. PQS. So we found it, that is 80 degrees. Now QPR. QPR. QPR is this. QPR. Very easy. I know this is 80 degrees. I know this is 33 degrees. Angle sum of a triangle. It will give you 20. It will give you 67. 67. How? 180 minus 80 plus 33 will give you 67. Now, do we have any third angle left? Yeah, PSQ. PSQ. This angle. PSQ. This angle he is asking you. Pretty simple, guys. This angle I can easily find it, which comes to me 147. What's the reason? Because this is 180. And then I will subtract from 180 the sum of 21 and 147. 147, what is that? Let me check. Yeah, so it will give you the answer 12 degrees. Yes, it will give you 12 degrees. Next question. The question looks more complicated, but inshallah we will easily solve it by using the properties. I can see here the guy has used parallel lines. Did he mention anywhere diameter? No, he's talking about a cyclic quadrilateral. So what I'm going to do first, look at the corners D, A, C, and B. All the four corners on the circumference, it means ABCD qualifies as a cyclic quadrilateral. So this angle is completely known to me, which is 82. So this angle is 82. So the opposite to 82, I can also write this angle. That comes to me 98. Why 98? Because 180 minus 82 will give you 98. So let me erase everything. So the total angle comes to me 98. Now use the property of angle in the same segment. If I use this arc that produced an angle here 20, on the circumference, and also if you produce the endpoints of arc AD on other point on the circumference, which is B point, join them, you'll get the same angle. So this is 20, this is 20, so this has to be 20, right? I can also use the arc AB, which produced angle here and here. So this is 62. Imagine I'm using angle in the same segment property and the cyclic quadrilateral. I could able to write as many angles as I want. Now 62, 20, 98, everything is done. I want to find first DBA. Where is DBA? This is DBA. That is 20 degrees the angle in the same segment. 20 degrees. Next, DAB. DAB. That is 98 degrees. We found it. DAB. DAB. 98. Cyclic quadrilateral property we used. Then DAC. DAC. This angle he is asking you. I need to use the parallel lines because still I didn't use it. Let me explain you how. This is 20. Guys, the Z concept. Look, this, and this. So if this is 62, that has to be 62. I used the parallel line Z concept. So this line is parallel to this. So I completed the Z and I found 62. The total one was 98. And so that one should be 36 because total is 98. 62. We found it. So this angle is 62. Now AXB, AXB, this angle. So we can easily find it. This is 36, this is 20. We can subtract 36 and 20, the sum of 36 and 20 from 180, and then it gives you 124. No need to mention it. And 180 minus 36 plus 20. Later, you can calculate it and it will be 24. So this is 124. CDB, CDB, this angle. Guys, angle in the same segment property. So if this is 36, that has to be 36. Question number 68. We have here a cyclic quadrilateral because all the four corners are on the circumference. Can I take the opposite of 126, which is P? So P will be equals to 180 minus 126. It gives you 54. And also, this is a straight line. I can easily find Q. So Q will be 180 minus 75 plus 54, and that gives you 51. As per the rule, as per the rule, we already know that the tangent from the external point has same lengths. So it makes an isosceles triangle. This is 51. This is also 51. I can find this angle, which is found by angle sum of a triangle. So it gives me 78. 180 minus 51 plus 51. Do we need to find any other angle? Guys, alternate segment theorem. If this is the chord making an angle 51, so this angle should also be, because this chord is produced back, this angle also needs to be 51. I think all angles are found. So this is 54, this is 51, this is 78. Now he's asking you which triangle qualifies as a cyclic quadrilateral. You can see these two angles, their sum is 180, and these two angles, if you add them up, your sum is 180. In this triangle, the opposite angles are not 180s, maybe one of them, but here the two opposite, yani, there are two pairs of opposite angles. So this is 180 and this is 180. So I can say the quadrilateral B is cyclic. The others are quadrilateral, but they are not cyclic. Their opposite angles has to be supplementary, and their sum must be 108. Next, if you can see, we want to find the value of y. Guys, two equations you will try to make. This plus this has to be 180. Can I try to get the value of x? So 2x plus x plus 60 is equal to 180. So 3x is equal to 180. Send the 60 to the other side. So 2x is equal to 120. So x is equal to 60 degrees. Let me check. Is it right? 2x plus 3x. So it's 3. It's 3. So 120 divided by 3 will give you 40. So x is 40. Then I'm going to use the opposite angles here, second pair of opposite angles. Their sum should also be 180. So 3 4x minus 87 plus y is equals to 180. What is the value of x you found? 40. Substitute it here. So that is 40 minus 87 plus y is equal to 180. This is 160 minus 87 plus y is equal to 180. And then finally, this is 73 plus y is equal to 180, and then y will be 180 minus 73, because 73 goes to the other side. It gives you finally 107. So y is 107. Very important question, because it has lots of steps involved, and you need to use algebra inside it. The next question, guys, if you can see, he has given you a chord and he gave you a tangent. The alternate segment theorem tells you any angle which the chord makes with the tangent, that angle is always equals to, if the chord is produced back on the circumference, and that angle will always be same. Okay, so 64, 64, we found it. Now cyclic quadrilateral. Why cyclic? Because A, D, C, and B corners, they are making a cyclic quadrilateral. So the opposite to 64 is angle B. So I can easily find it. 180 minus 64, that gives you 110, 116, sorry. So 116. What are the reasons? We use two properties: alternate alternate segment theorem, and the second property is opposite angles in a cyclic quadrilateral are supplementary. Next, 72. In 72, guys, you can see at first we have here this angle, by alternate segment theorem. This is a chord and this is a tangent. The chord and the tangent, they are making angle 47. So did he produce the chord EF back on the circumference? The answer is yes. He produced it here back. Wow. So this angle should also be 47, number one. Then angles angle in the same segment, did he produce the arc, the endpoints of the arc GF anywhere on the circumference? The answer is yes, here at E and also at H. What are the angles? This is 25, so that has to be 25. Wow. So we found these angles, 25. Next, he told us that this triangle is isosceles. Why? Because these two sides are equal. If these two sides are equal, their opposite angles are also equal. So what is the sum of 25 and 47? That tells you 72. So this is also 72. I can easily find x. 180 minus 72 plus 72, and that gives me 36. Now come to the 73. In 73, you guys can see I want to find CBO. CBO. Okay. Um, this is radius, and this one is tangent. You remember, radius and tangent, they are always making 90 degrees. So this is 90. So that has to be 40 degrees. This is 40. Next, all of you also remember this is tangent and this is radius. They are also perpendicular. Now, in the triangle D, right angle triangle DAB, you know 90, this is 40. I can find the third one. So 90 plus 40, we subtract them from, their sum should be subtracted from 180, it will give you 50 degrees. So that is my 50 degrees. He's asking you which angle. Let me check. DOC. Oh wow. So DOC, this angle he is asking you. So the half of this angle is, because this should be 25 and that is 90 degrees. I can find this DOC angle. The DOC angle is 90 degrees plus 25. Take the sum and subtract them from 180, it will give you 65. So this angle is 65 and this angle is also 65. This is 25. Next question, 74. Guys, you can see angle in the same segment. This arc is produced back on the circumference here, and also it produced back here. So if this is 58, that has to be 58. Done. Second thing, the guy told you this is your diameter. So did he join the end points of the diameter anywhere? Yes, he joined them here at point A. So that has to be 90 degrees. So let me erase everything. So this is your 90 degrees. I can easily write this angle. That angle comes to me 32. That is 32. Now what else is needed? So this angle is also 58 by using the isosceles triangle, because this is radius. So OAB um, is an isosceles triangle. So can I find it as the total angle? This is 90 degrees, but I want to find this angle. So this angle has to be 58. 8. So this angle is, since this is isosceles also, this is 32. That has to be 32. Okay. What else is needed? I found, I think, every angle. Since this is 90 degrees also, because the radius and the tangent and the radius, they are making 90 degree with each other. So total is 90, and I want to subtract 58 from it. Mm, or what I can do now, guys, because 32 is found, 58 is found. Is there anything left? I just want to tell you guys, 34. Hold on. I don't want to make it complicated for you. So that's why it's better to use one more angle in the same segment concept. Angle in the same segment concept tells you that this arc is producing here 34. So this angle is also 34. Wow, this is 34. And the total is 58. So from 58 you subtract 34, it gives you, from 58 you subtract 24, it gives you 24. So we got 24. That's all. No need to go into any other reasoning. So as you see, this angle has to be 32 by angle alternate segment theorem, but it is not required. Let me copy all the angles which I found: 58, 32, 58, and 24. Next, if you see this question, um, this is 24, this is 90. As everyone knows, radius and tangent, they are making 90 degrees. I can find this angle, that is 66. Oh, after a long time, this property came. What is the relationship of the angle at the center and angle at the back? Any? If you have a circle and there is an arc AB whose endpoints are joined on the center, and also they are joined back on the circumference. So the relationship is, if this is x at the center, we always get a double angle. So 66, so take the half of 66. So 66 divided by 2, that should be 33. So this angle is 33. And this is 90 degrees, that is 33. This is 33. And then I will try to find this angle also by alternate segment theorem. This is 33. Why? Because this is 33. Look, if this is 33, that has to be 33. Now 33 and 24 will be subtracted from 180 to get the required angle ABT. So let me copy all the angles which I found: 66, 33, and 123. I want to move on to the next question, number 76. So 76 we have here. Why not? I can use the property which is called angle at the center is always double than the angle at the circumference produced by the same arc. So this angle is produced subtended by the arc at the center, and also it is producing the angle at the back. So is there any relationship? Yes, there is a relationship. That's 70 divided by 2, which is 35. Your E is 35. Done. Next thing is, this is radius, so 70, this is x and this is x. I can easily find these angles, um, which are not harder for us. Mm, Guys, could you please tell me that if this is 70, I wrote here 35, is any angle given to us? This is 70. This is 70. I can write this angle also 35. Can I find G? G is, let me check which property I can use. This is 70. Is there any diameter given to me? Yeah, very good. Let's go start the question because I don't want to make it complicated. This is radius and this is a tangent. So the total is 90. Got it? As you all see that I have written this one as 70 divided by 2. This is 35. So 90 minus 35 will give you, this is 90 minus 35, that gives you 55. So if this is 55, that has to be 55 angle in the same alternate segment theorem, because you remember if this angle is 55, that has to be 55 alternate segment theorem. Then the last one is the cyclic quadrilateral property, that all the four corners موجود on the circumference of this quadrilateral of this on the circumference, that all these four corners are on the circumference. So it is WTXU is called cyclic quadrilateral. So the opposite angles are supplementary. I can easily find H. H is equals to 180 minus 55. That gives you 125. So let me copy all the angles: 35, 55, 55, and 125. Are we done? I think question number 78 we came on. Wow. So the guy gave you um, this angle 70 degrees, and in this arc, I'm going to use the property angle at the circumference and angle at, why not we can use the cyclic quadrilateral property first, because these four corners, these four corners are on the circumference, right? Um, so if this is 31, I can find this because this is opposite to that. So that gives me 49. And when I do this, 180 minus 131, that gives me 49, boys. So this is 49, and that is my 28 or 29, sorry. Done. Now, after writing this angle 49, the total angle is 49. Now, can I use it here? And if I'm going to use this arc, it is producing an angle at the center and also producing the angle on the circumference. This is 49. At the center, the angle is always double. So 49 times 2, which is 98. So this is 98, we found it. Then you know that, guys, this angle is 20 degrees and it is produced by this chord, and this chord is making angle with the tangent. So can I say this is also 20 degrees by using angle at this alternate segment theorem? Next thing is we have total 90 degrees. Why? Because the radius and the tangent, they are making 90 degree with each other. So 90 minus 20, that gives you this one 70 degrees. Okay. Any other thing which is required? I think we are done with everything. So let me copy the angles: 49, 98, 20, and 70 degrees. Question number 78. OCD angle, we want to find it. Let me try to find all the angles for you. This is for 90, guys, and this is isosceles triangle. So that has to be 45 and 45. Next thing, If this is also isosceles, so 50, I can find this angle, which is 65, and this is 65. I can find this angle also by subtracting 65 from 123. That gives me 58. 58, yeah. This is 58. So this is 58 isosceles triangle. It helps me to find this angle 64. What else is needed, guys? He said find OCD. OCD is 65. We found it. TDC 25. TDC 25. Did we find it? T TDC. Yeah. This TDC is how much? It is 25. What's the reason? Because we have a radius and we have a tangent. They're making 90 degrees. So from 90 degree, you subtract 65, it gives you 25. We found this angle also. So 25. So ABC angle, ABC, yani we want this angle. So 45 plus 58 will give you 103. 45 plus 58 will give you 103. Last reflex angle, guys, be careful about that. AOC, they're making obtuse and reflex. So AOC, this is obtuse, and this back angle is called a reflex angle. So I want reflex. First of all, I need to find this angle. I need to subtract. I need to subtract the sum of three angles from 360. It gives you 156. So this is 156. To find the angle AOC, so 156 plus 156 plus 50 degrees will give you 206. Yeah, 206. Khalas, guys, we are done with the circle properties. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.